Okay guys, here's our first segment on the different types of molecules and compounds that we'll be naming. The first one that we'll be working with is simple molecules. If you can recall, when it comes to our process through which type of molecule we have, this is the very last one. This is the one in which it's not a metal, does not have hydrogen, it is not a hydrocarbon. So what we're left with is just a simple molecule. Our simple molecules, if we recall, are covalently bonded nonmetals. So you should find everything here is nonmetals. And because we are covalently bonded, that means that we're sharing electrons. So when we share electrons, we can do so in more than one ratio. We can have a 1-to-1 ratio, a 1-to-2, a 2-to-2. There's lots of different ratios in which we can share our different elements. So because we have more than one possible ratio, we need to use prefixes to identify how many of each substance we have in our compound. Now we have 10 prefixes that we're required to use. Our first prefix is mono. Mono stands for 1. Our second prefix is di, which stands for 2. Tri, which is 3. Tetra, which is 4. Penta, which is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona is 9. And then, of course, the last one, deca, is 10. Okay. Most of these prefixes you should be familiar with. They should match what you guys did in your geometry class, using your different geometric shapes, your pentagons, your hexagons, your heptagons, those kind of things. A couple of things to make note of. Make sure with tetra for 4, you're not trying to use some of the other possible things out there for 4, like quad or bute, but we're using the tetra prefix here. And then again for hepta, I know in your geometry classes that septa was an acceptable way of doing it. I do not do that, nor does the chemistry world. So you must use the hepta prefix for 7 for those. Okay. Now working with these different prefixes, we have to be able to both name the compound and write the formula. So let's start off by talking about naming those molecules. We have our diatomics, which are 2 of the same element put together. So for example, like F2. When we name these, we don't use any prefix with those. We just name it the same as we would the element's name. So we would just call F2 fluorine, like Cl2 would be chlorine and H2 would be hydrogen. We don't give any different name to our diatomics. When you have a binary molecule, binary meaning 2, we have 4 examples down here, SF, SiBr, OI, ClO, where you have 2 different nonmetals put together. We need to go through and name those different nonmetals now. First step, identify the symbol, and then write them in the same order as they come in the formula. So for S2F4, we start with sulfur, so we write sulfur first, and then we have fluorine, so then we write fluorine. The difference is, though, for the second word, on our second word, we replace the last syllable with IDE, okay? Then find the right prefix for the subscripts, place the prefix in the name, and you're done. A couple things to note, we don't use the mono prefix on the first nonmetal. If it's on the second one, we do, but for the first word, we don't use mono ever. It's just assumed to be there if we have that. Okay, so let's do a couple examples on the board here to see how that would work. So let's start with S2F4. So S2F4, S is sulfur, and we have 2 of those. So the prefix for 2 is di. So we would call this di-sulfur. Notice how we do not capitalize it, because we do not capitalize these are not proper nouns. And then we have 4 fluorines, so that would be a tetra. And fluorine we change to fluoride. So it would be tetra fluoride. So S2F4 we would call disulfur, all one word, space, tetrafluoride. Same thing for SiBr7. Si is silicone. It's one of them, but we do not put mono on the first word, so we just leave it as silicone. And Br, we have 7. The prefix for 7 is hepta, so we would call this hepta bromide. Okay. Now, as we do these examples, a couple of things to make note of when you're changing your endings for oxygen, nitrogen, and phosphorus. If this happens to be your second word for any of these three, we need to make sure that we cut the word properly. So for oxygen, we're going to get rid of the -gin, for nitrogen, the -ogin, and for phosphorus, the -orus. So we kill all or double or two of those syllables at the end, not just one syllable. So oxygen becomes oxide, nitrogen becomes nitride, and phosphorus becomes phosphide in our system, okay? Everything else, you just drop off the last syllable. So it would just be chloride, bromide, iodide, those kind of things, carbide. But for these three, we drop off the last two syllables. So please make sure you get those into your notes. Also, when we're doing our prefixes with oxygen or iodine, because they start with a vowel, we have to change how we put the prefix on a little bit. So for oxygen, for mono, or any prefix that ends in an A, so that could be hepta, deca, nona, penta, hexa, tetra, anything that ends in an A, for oxygen, we want to drop the A or the O. So for mono, we would say mon oxide. We don't have monoxide, so we get rid of the extra O. And the same thing, let's say for tetra, we would drop the A and just say tetroxide here. So tetroxide, not tetraoxide. Okay? So for oxygen, remember to drop your A and O endings if you have that. So you have monoxide, tetroxide here. Okay? If it has an I, like di and tri, these we keep. So you do say dioxide and trioxide, you leave the I in. Okay? You don't drop it like you do the O and the A. However, for iodine, because it begins with an I, your di and your tri, you do drop the I's here. So for these both, we drop the I when we name this. So for iodine, you would say diodide with only one I in it, or triodide with only one I in it for these. Okay, so a couple little details when it comes to putting the prefixes on we have to remember to do. If you don't do those things, I do have to count it wrong because that is not the right way to put those things in, and we're going to make sure we do it the right way. Okay, a couple more examples. If you take a look on our screen here, we have O2I3 and Cl5O9. So if you want to try these on your own, you can just pause the video. Otherwise, I want to show them to you now. So if we look, we have 2 oxygens, so we call this dioxygen. And we have 3 iodines, so it would be triodide, so dioxygen triodide. We have 5 chlorines and 9 oxygens, so it's pentachlorine, non-oxide. Make sure that only the second word you're changing to the IDE endings. Notice how oxygen and chlorine are not changed for the first word there. The second part of this is writing the formulas when you're given the names. So it's the same process, we just run it in reverse. Again, we identify the symbol, write the symbol in the same order as the name was written. Whatever prefixes are there, you write those down as subscripts. One thing to know, you never use a subscript 1. It's assumed that there's no number present. So for disulfur pentoxide, The di here tells us we have 2. Sulfur's symbol is a capital S, so disulfur would be S2. The pent tells us we have 5. The symbol for oxygen is a capital O, so we have S2, and pent tells us 5. So we have S2O5 would be our formula. Okay, there is no space between these. I don't want you to think that there is. So written all as one grouping, S2O5. If we follow the same thought process for chlorine, trichlorine octafluoride, we have 3 chlorines and we have 8 fluorides. And then carbon monoxide, we have 1 carbon and 1 oxide. So we should get those formulas accordingly.